All right, so here we have a problem dealing with the question, does seat location affect grades? This is actually a pretty common question that you probably have heard of and probably even thought of about yourself, or like, does sitting in the front row, next to the teacher, is that actually good for me? Or is it just the teacher wants to be next to them? It makes me think that I'm gonna be paying attention and doing better, blah, blah, blah. People actually, actually wonder about this. And let's let's see what this data says, because there's actually been several studies done. So here it's saying like many people believe that students learn better if they sit closer to the front of the classroom. The sitting closer causes higher achievement, or do better students simply choose to sit in the front? Yeah, so that's the question, right? I'm sure that's what I and many of you have been wondering. So to investigate, an AP Stats teacher randomly assigned students to seat locations in his classroom for a particular chapter. At the end of the chapter, he recorded the row number, row one is closest to the front, and test score for each student. Least square regression was performed on the data. A scatter plot with the regression line was added, shown here. The residual plot was also here, and some computer output from the regression is shown below. All right, so this is a good problem for you to get a feel the types of free response problems you'll have dealing with regression. And they're actually pretty simple because they really just require you to understand how to interpret the data. So once you can do that, these problems are actually pretty simple for most students to do. My students usually do really well on them because this chapter is pretty like natural for you guys to understand how how it relates to real life situations. So let's go through this. So the first thing we have to figure out is what the equation of the least squares regression line is. And in this case, it's going to be the line that describes the relationship between row number and test score. So row number is the explanatory variable, score with the response variable. And we're going to need to define any variables that we use. So here, we're going to focus on this first column here. This stands for coefficient. These are the coefficients. The coefficient of the constant, which is 85.06, that'll be your A value. Remember, we're dealing with the linear equation, y hat equals A plus bx. That's the typical form we'll have in statistics. So A is like your constant or y-intercept. Your B is the slope of your, explanatory variable x. So the coefficient constant, or just the constant, is A will be that number right here, is 85.706. And this will be the coefficient of the row, or the B. So this is your A, and that's your B, A, B. Because this means the coefficient of your variable, which is row, and your row is your x variable. So our equation will be y hat is equal to 85.706 minus 1.1171x. That's our equation for our least squares regression line. Make sure you put y hat. That does make a difference, and they will score you down if you don't. Use that notation, use a little hat. Now let's define what x is and what the y hat is. So x represents the row number, and then y hat, make sure you put y hat, represents predicted score. Oh, my pencil's exploding here. Represents predicted score. Predicted score. All right. We got that down. All right, part B. Let's interpret the slope of the regression line in context. Okay, so the slope is this number right here. Remember our negative 1.1171. That's the slope in this problem. Now let's think exactly what that means. Not just like, you don't just say, oh, it talks about, it describes the row. No, it describes how the row changes in terms of the score, or how the score changes in terms of the row. You have to be very specific. It does matter. So remember, though, when it's when it's simply just a number, it's always technically a fraction because you can write any number over one. So just remember what you learned from algebra. If you need a little refresher, remember it's change in y over change in x. The change in y, or the change in row number, is negative 1.1171. The change in the change in score, which is the y. The top is the change in score, which is going to be negative 1.11. I guess it's a very small number. And the bottom is a change in x, or a change in row. So it's basically saying that each time the row goes up by one, the score is going down by negative, or going down, you don't say negative, I guess, is going down by 1.1171. So now in context, what is that saying? And again, just use your common sense of what you can say about what this is going to look like in real life. As the students sit farther away from the front, their score is decreasing. And specifically, based on this equation, for each additional row that a student sits farther from the front of the room, their score is predicted to decrease by about 1.1171 points. All right, so here it is. Here I wrote it out. Make sure you write this out in a complete sentence. Remember, don't be lazy about this, because the graders can't, they don't know you. They can't read your mind. And be careful about this part, because sometimes it could be kind of a little confusing. If you say decreases, you don't have to say decreases by negative, because you're saying decreases by negative, that actually means going up, and vice versa. So be careful about that. We're saying, since I said it decreases, that rate means that I'm taking care of that negative, because that's what that negative means. All right, part C, find the correlation. Let me write that. Part A, part B, part C. Now, part C, we got to find the correlation from this data. And remember, the correlation is the R value. Now, we're not given R, but this is actually given as, this is actually what R squared is. R, it's written as a capital R. That's just the notation, R dash square. So R squared is 4.7%. It's written as a percent, so as a decimal, it's 0.047. Now remember, this is R squared. We're not given R, so we define R by simply taking the square root of this. R will be the square root of 0.047. And then that'll be about 0.217. Now here's the thing. Let's be aware of the sign of the correlation, because remember, the sign of the correlation matches, the behavior or the trend of the graph. See, since the points are decreasing, or the score is going down, the line is turning downward, the relationship is negative. So that means the R value is going to be negative. So make sure you make the R value negative. That's really the only way you're going to be able to tell that, is by understanding the relationship of the graph. When it has a negative slope, when it's turning downward, R is going to be negative. If it's positive going upward, R is positive. All right, and the last one is align an appropriate model to use for these data. Explain how you know. Okay, so going back to the concept of residual plots. Remember, a residual plot is a way to tell you if it makes sense or it's reasonable to use a linear equation to represent the data, to represent the scatter plot of the data. By looking at the data like this, it's like you can't just look at it with your eyeball and be like, oh yeah, straight line predicts that. what we technically don't know if maybe a curved line will be better or will make more sense by just looking at it. Remember, we can't just trust our eyesight. We were not, not built for that. So what we do is we make a residual plot, and if the residual plot just shows like random scatter, if there's no obvious pattern, there's nothing like clear, that's that we can say, oh, there's a very clear pattern. We don't want a pattern. We want some mess of points, and that's what we got here. We got a mess of points, no obvious pattern in the residual plot. So we're good. So then it will be okay to use a least squares regression line for this data. So we will say yes. Yes, because there's no obvious pattern in the residual plot. Is there obvious pattern in the residual plot? And I recommend just keeping your answer short and to the point, because sometimes you can say something that's incorrect, and the graders are pretty strict. If you add stuff that's incorrect, even though your original answer was fine, so just be careful about that. And that's all there is to it.